Okay, so the next couple of lectures are all about file handling and sort of a development from what we did in the last lecture, in that instead of reading and writing permanent data to a console window, we're going to look at the way that Java allows us to read and write data to external files, so that we can write data to it and then open it up in Notepad or a text editor, so we can see how the data's actually been manipulated. So we're used to the concept of a file. We're used to the concept of word process documents, images, source code for programs, and in the end they're written in exactly the same way, in that all they are just collections of binary. But the main two file formats, whether they're Word documents or Excel documents, or it doesn't really matter, is that they're either held in text file format, in which case the data is stored as what we call ASCII, so there's an individual code for each letter, or they're stored as binary. Now, most things like word process documents and Excel documents are written as binary so that they're understandable by that application, and ASCII files are more easily readable by humans because they're written as standard text. And what we're going to be looking at today are just ASCII files. So we need to know the two main classes which are used by Java to allow us to write to files. We're only going to concentrate on writing to a file in this lecture. We'll cover the reading in the next lecture. And the two main classes that we're going to look at are the file writer, which is what we use to allow our program to look at a file, and the print writer, which allows us to actually write the data to the file. And both of these packages you will need to import into your Java programs, and they're actually part of a separate package called I/O. And all we have to do to get the functionality into your Java program is to use two import statements. We're used to using import statements now because we've already used them in other functionality, for example using random numbers, and all we do is we use these two import statements at the top of our program. So we would write import java.io.filewriter, which allows us to use the ability to connect to an external text file, and import java.io.printwriter, which will give us the functionality to actually write the data to that file that we've connected to. So we'll start off with the file writer object, and the context of a file writer object is that we have to give it two pieces of information. One is the name of the file that we want to write the data to, and the second bit is what we call the append flag. Now, the file name is an easy one. It's just a string, and you just put the name of the file in the string, and eventually we're going to look at using file paths and things like that, but we'll come to that later. The second part is the append flag. It's a Boolean, and you either tell the file writer that you want to append data to a file that's already there. Now that means if the file's already there and that append flag is true, it means that you're just adding data to it. So it ignores the data that's already in there and appends new data to the end. If the append flag is set to false, you're almost treating that file as if it's a new one, and you want the file writer to overwrite what's already there. So it's important that you understand the nature of the append flag in the file writer, because if you get it wrong, you could overwrite the data that you've already created. There's an example of a file writer in use. Now, I've been teaching this module for a couple of years now, and I tend to leave the variable names. I use FW for file writer because it's pretty straightforward. So we create a file writer instance, and then we create the file writer object, and then we create the instance. And in that file writer object, that's the name of the text file we want to connect to. And in this case, we've set the append flag to true. And what that means is when we write data to that student text file, we will add new data onto the end. We won't overwrite stuff that's already in there. One thing that is quite good about this file writer object is that if there isn't a file, it will make one for us. So if student.txt doesn't exist, it will create it for us. Print writer object is reliant on the file writer object. So assume we've already got a file writer object using FW. We create a new instance of a print writer object using the file writer object so that we can write data to the file created from the previous file writer. And there's only two methods belonging to the print writer, which are print and print line. Now, if you've watched the previous lecture relating to writing to the console window, it uses print and print line, just like what we looked at with system.out. So the rules are exactly the same. We can say pw, which is our print writer.print, and it'll write that text to the file. Now remember, .print doesn't add the return or the carriage return onto the end of the string. pw.println will write a line of text to the file in the file writer object, but println will press return at the end and leave us writing on a clean line. When we've done all the printing that we want to do, we just close the file writer object, and then the file writer object just closes the file, and if we need to use it again, we'll have to open up a new file writer and print writer object. So what we're going to do is stick all that together in a single application, and it's going to be called class list, and we're going to output students' names to a file called students.txt, and we're going to use a method called addStudent, which is going to take two parameters. One is the student registration number, one is the student's name, and then we're going to write those two pieces of information to an external file called students.txt. So in order to do that, we'll go through the stages. We're going to use two import classes at the top of the program to import the file writer and print writer functionality. We're then going to store the name of the file that we're going to write to in a constant, and this is the addStudent method. And what we've got is the name of the student, name of the method addStudent. It has two input parameters, one called pStudentName and one called pRegNumber. And then inside this method, we're going to create the instance of a file writer. Student file is students.txt, which is from the constant, and we're going to set the append flag to true so that every time we add a new student, we add it to the end of the file. We don't overwrite the same one over and over again. We create the print writer connecting to our file writer object so that we've got the ability to use our commands to write to that file. And then in the print writer object, we're going to use the print line command, which will be a student name and then a tab. Now a tab is /t, so it'll be the student's name, a tab, and then the reg number, which will get written to the file. and then we're going to close the connection. Okay, so they're all the file handling elements that we need to include until Java actually forces us to add a little bit more, and that's all to do with error handling, because potentially when you're talking to files that are outside of your Java program, there can be problems, so we need to be able to handle those errors. And we can write perfect code. We can write our file handling code, it works completely fine, we know it, we've tried it before, we might have even used it in other programs. But there are errors that can happen outside of our control. For example, we might try creating a file with an invalid name. It might have slashes in it or something like that. We might have a file that's writing to a file that's read-only. It might be in a read-only directory. In the other extremes, we might not have the hard drive space to write the data. We might be dealing with storing a file, for example, on a hard drive that's almost full. And the thing is that we don't have the capacity at the minute to deal with that kind of error. What would happen is that the operating system would tell the Java program that this error has occurred, and at the minute, with the code that we've got so far, we will probably crash our program. So we have, as part of the Java rules, we have to write something called an exception handler in order to cope with it. Now, the rules are that because we're dealing with external files, Java forces us to use this IO exception handler. If we don't, it actually won't compile. I mean, that's how serious it is. I mean, you know, it will. If we write file handling code without an exception handler, it'll just not compile. It'll say there's no exception handler. You've got to write one. So what we do is we use a structure called try catch, and that will detect and handle errors for us. And that's the structure itself. There's no code in it at the minute, but what we've got are two blocks. We've got a try block, and then straight after it we've got a catch block. In the try block, what we do is we try to run the code that we want to run. So as far as file handling is concerned, we will try to run the code in here. We will try to run our file handling code in here. Just like what we wrote before, we'll just put it in there. If something goes wrong, like it's a read-only file, or the file's corrupt, or the file isn't there, that would create one though, it will run the catch block. Now the catch block will receive data from this exception handler. You don't have to use an import statement, you just have to make sure you type that in as part of the exception handler. And then what we'll have to do is write some statements to handle it. It could be user.message or something like that. So the whole add student method now looks like this. This is our try block. Now that's the sort of the easy part of it, because that's got everything we've just talked about writing data to and from files. So there's the file writer. There's the print writer, there's the print writer print line to output the data, and that's the closed connection. This is the catch block. The catch block basically will catch any errors if they happen, and all it'll do is say user.message, so you need the user class, something's happened, and it'll tell us what that exception is. Now that's what IOE is. That's the IO exception that we're getting from, basically from the operating system, to tell us what the error is that's actually occurred. So let's have a little look at how that happens. Okay, so I've downloaded class list from the VLE, and I've just opened it up in BlueJ. We'll give it a quick compile, there shouldn't be any issues with it. And what we'll do is have a quick look at the class list code. So what we've got is a constant, which is a string. I've set it to students.txt, and we don't have any other variables, and we don't have anything in the constructor, so it's a little bit more simple to get on this one. All we've got is the code that we've demonstrated in the PowerPoint. So what we've got in our add student class are two parameters, one for the student name and one for the reg number. And they're both strings, so there's implications with that, which you'll see in a minute. This is our try block, where we create an instance of a file writer. So those are the two import statements: import java.io.filewriter and java.io.printWriter. So you have to put those at the top of your class. So those are file writer and print writer class definitions all set up. One thing I will mention is in our file writer, we've used the student file constant, which is students.txt, and I've set the append flag to false. Now I'm going to show you both ways. I'm going to start with false, demonstrate how that works, then I'll show you with true to demonstrate how that works afterwards. Then what we do is use the print writer print line statement to write the student name, and then a tab, and then the student's registration number to the file, and then we're going to close it down. And just in case there's any problems, in our catch block, we have a catch block there. We output an error message, and we actually output what the exception is. We're going to look at exceptions in the next section after this, so I'm not going to worry about the exceptions for this section. So what I'm going to do is, initially I'm going to open the folder that the program lives in, because at the minute when you download it, there's actually already a student's file as part of the package, and I'm going to delete it because I'm going to get the system to recreate it for us. So this is going to test our program even further, because if the file doesn't exist, the hope is that it will create one for us. So what I'm going to do is create an instance of a class list. I have to leave the default name. Then what I'm going to do is I'm going to call add student, and it's going to ask for two pieces of information. Now, because we've got parameters and the strings, you have to put your strings in quote marks. So I'm going to create Paul, or write student Paul with registration number ABC123. Now, you should find that the student's file has already been created, and if I open it, it's written that data to the student's file. Okay, so let's run it again and put some different information into it. So in this particular case, we'll add John and DF456. Now what you should find now is that the file already exists, but it's overwritten the existing data. So what we have to do is show you why that's actually happened, because if you open it up in the editor, we set the overwrite flag, or the append flag, sorry, we set the append flag to false, so it will treat it as a new record every time. If I was to set that to true and recompile it, we've got one existing student in there, but now if I add another student, let's just create a new instance again, and call add student, and I add Dave with registration number GHI789, we should find that when we open the students file, because the append flag was set to true, we're now appending the data to our text file. Okay, so obviously the next stage from this, the writing data to external files, is pretty straightforward. What we need to do is try and demonstrate how we can show that the catch part of the code works. So we need to be able to try and force exceptions. It's not actually that easy because a lot of things are actually done for us. We've got a fixed file name, so we know that the file will be written to if it exists. We know that if the file doesn't exist, we know it will create it for us. We know that if the file exists, we now know how to append data to the end, and we have the file in our own project directory. So at the minute, everything's really sort of good for us because we don't really have any problems. So finding the ability to generate an error is actually quite difficult. I'm certainly not going to fill my hard drive up in order to try and test out, if there's not enough disk space. So the only way we can really force an exception is by entering file names, incorrect file names in that respect. So what we're going to do is we're going to, in class list 2, what we're going to do is we're not going to have a static file name. I mean, realistically, if you're thinking forward to the assignment, you're going to have a fixed file name anyway. But for testing purposes, what we're going to do is set up a parameter to the constructor which will allow us to sort of set the file name up and store it in a variable. But what we're going to do is set up some situations. As an example, what if we use an empty string as a file name? And what if we want to save our file in a different directory by typing in the full path of where we want to store it? So let's have a quick look at that. Okay, so I've downloaded class list 2 from VLE, and I've opened it in BlueJ, and I've just quickly compiled it. So let's have a very quick look at the code. Some very minor changes have taken place to it, so I'll just go through those with you. The import statements are the same. The only minor difference is that we've got a variable instead of a constant to hold the file name. So I've declared a now privately declared string called mFileName. The constructor now has a parameter of pFileName, so that when we create a class list object, it's going to ask us for the name of the file that we want to write to, and we're going to set that to the name of the file that we want to write to, and set that variable mFileName to it. When we call add student, it still takes the same parameters, but instead of writing to a constant variable, we use the variable mFileName, and notice we've set the append flag to true. Everything else is exactly the same on that one. The only other thing I've done is I've just added a new method called setFileName, so potentially I could change the file name while the program's actually running. So I've got a setFileName method which will allow me to change the name of the file as the program's running. I've got a parameter, the pFileName, and I'll just change the file name inside there. So what happens? Well, what I'm going to do is I've set up already an external storage location for this file. So I'm not going to store it inside class list 2. In fact, inside class list 2 there's actually no text file set up. But what I've done is I've set up a temporary storage location which is ctemp, which is on this machine that I'm recording this video on now, and I'm going to write the file to that particular location. And I'm just going to show you some of the potential problems that you might have when dealing with this sort of a setup. So the first thing I'm going to do is when I create my instance of a class list, it's asking me for the path to the actual file that I want to write. So I'm going to create it in that ctemp directory. And obviously it's a string, so it's going to be c temp and we'll call it wibble.txt. Okay, so what we're doing is we're creating a path in our ctemp directory, and what we're doing is setting it up so that we write to this particular location. Now, the problem that we've got is that it's telling us that there's an illegal character been set up, which basically is Java's way of saying, look, you're using characters that you're not allowed to. So you're going to have to sort of be careful with this, because if you remember, if you use /t, it's actually an indicator of a tab. So when you're setting up paths, you can't use /t. So the weird thing about it is that you have to set up another way of setting up a slash. Now, if you use two of them, this should work. Yeah, you have to use two slashes in order to set up a slash mark in a path, which is very, very strange, but that's how it works. So if I attempt to write to the file now, for example, I add Paul and ABC 123, it should now write our data to our external file. That's been set up in ctemp now, and you can tell that data's been written. And again, if I add another student, you should find that that's been added as well. Okay, so yeah, the problem that you're going to have is if you set up a different file name. So I'll set up a different file now. If I use the traditional way of setting it up, so I say c temp wobble.txt. Whoops. It's going to say, look, you can't use, you're using an illegal character, which is the /t. So you have to use two slashes in order to get it working. So if I again attempt to add a student, I'll just put rubbish in this. It will then follow the path. So just to summarise that sort of error message setup that we've just seen, if you attempt to change a directory using single slash marks for the separators between folders and directories, you will get error messages. In fact, what you might get if you output the exception is that it actually uses the /t and thinks it's a tab, and then it'll just remove it. So you end up with something that looks like that, which clearly isn't what you're looking for. So what we need to do is understand this concept of /t's being escaped tabs. Okay, so what we need to do is, instead of using a single slash as a character to separate out folders and files and directories in strings, we just use double slash marks, and it will accept that. So if, for example, you were using a variable to store a full path to a project, a file in a project, like this one here, where we're using a constant, you would have to use the double slashes in order to output those. There are lots of others for that. A /t will be a tab, /w double quote would allow you to use quote marks in your strings. Backslash single quote mark will allow you to use single quote marks in your strings as well. But if you're using a path to a particular file, don't use a single backslash. You have to use a double backslash. Okay, so this is sort of the end of the first part of dealing with file handling. But you need to remember that we need to import the file writer and print writer classes. We need a file writer object to point to the file. We need a print writer object to use the print and print line commands to write data to the file. All our file handling code has to have a try statement. We have to have exceptions dealt with using the catch statement. And don't forget that whenever we're using paths to external files, we have to escape our string characters in order for them to be used properly. And after we've done all that, don't forget you have to close your file writer object after you've completed your file writing action.